All right, so we are going to do 64, right? So I'm just going to do the, I was going to do some examples from the actual lesson he taught, but I think I'm just going to go through the practice problems. I think that's fine. Let's do this. Let's go through the new stuff first, and then for the practice problems, because you know they always throw that older stuff in there. So let's do the new stuff first, so we make sure we cover that, and then we'll jump back and we'll do some of that trig stuff, you know. All right. So let's do letter C. Letter C would be, so it's practice C. So let me write this out. So it's negative 5x plus, my eyes are blurry this morning. What's going on? Got my bifocals. So old. All right, my writing's terrible this morning. What's going on? 3x plus 4y, and that's 6. All right, so what we're going to do is we're going to do this by elimination. Again, I don't know, like, I didn't watch the video. I just looked at the lesson from the book, you know, and just went through the problems. So I'm not sure how much he talked about this, but there's basically two ways to solve these. They call them systems of equations. When you have two equations like this, and a lot of times you'll see it look like that. Does he do that in here? Yes. Yep, they do. Yeah, because I taught out of a book. I used to teach out of a book that they put that little brace thing on there all the time. And then the book that I'm teaching at this school where I'm at now, they never put that little brace there. So I don't know. Sometimes, most of the time, you do see that. So anyway, it means they go together. It means the value for x in this equation is going to be the same value of x for this. So if x is equal to 2, it works in this one and it works in this one. Does that make sense? So it's not like two completely separate things. They kind of go together, right? And whatever the y value is, that y value works for here, and the y value also works for this. Make sense? All right, so that's a key thing. So what we're going to do is we're going to try to eliminate, trying to get rid of one of the variables, either the x or the y. It doesn't really make any difference. I kind of have a preference. If you notice, this one is negative and this one is positive. These two are both positive. If there is one, they're not always going to give you one that's negative and positive. But if they do, that's usually, not all the time, but that's usually the one I want to try to get rid of. Okay? Because what I want to do is I want to add up. Oops, oh my goodness. I'm crazy today. I must have some kind of, man, what's going on? Maybe it's because I'm writing sideways. Is that what's going on? Now I'm going upstream. All right, one of these times, I'll tell you what. How's that? Look at that. See, solved it. Okay, so what we're going to do, I put a little line here. What we can do is we can actually add these columns together. And there's basic algebra rule that allows you to do that, but okay. So what we're going to do, if I added them right now, I still get an x and a y, don't I? I'd get a negative 2x and I'd get an 11y. And that didn't really help us, did it? But what I want to do is I want to try to make it so that this number and this number are exactly the same. One's positive, one's negative. So when I add them together, they'll add up to 0. Does that make sense? So right now they don't. So what I have to do is I got to figure out, and I'll tell you what, I'm going to move this away from that little bracket thing so I have some room to work with. And we'll get rid of that line. Right? Oops. Where's the delete button? There it is. All right, so what I want to do is I want to make this number and this number into the same number, right? So that when I add them up, they'll add up to 0. Does that make sense? So we got to figure out what we're going to make it. Well, it's just what do they call it? The least common multiple. It's the smallest number that both of these divide into evenly. All right, so how could you figure that out? Just multiply them together, right? And that's 15, isn't it? So what would I have to multiply this by in order to make it a 15? A 3. So now watch. Basic rule of algebra says this. Whatever you do to one side, you have to do to the other side. Okay, so I have to multiply the other side by 3. Make sense? Now, what am I going to have to do to this 3 right here in order to make it a 15? Make it multiplied by 5. So I multiply the left side by 5 and I multiply the right side by 5. Does that make a little sense? All right. So now what we're going to do is now we're going to do that multiplication. I may do this a little differently than he does it. Again, I didn't watch the video and I didn't see exactly how he set it up. I'm looking in the book and what's he do? Calls it equation 1 and 2. It's pretty much, yeah, he does say elimination. He's got a little title on that section that says elimination. And does he say by substitution? I don't see that he mentions substitution, but the other way is substitution, okay? And we will do one eventually here that is substitution. So anyway, what we're going to do here is go ahead and distribute. So what do we get? We get negative 15x, and then plus, make sure you distribute that 3 through this whole thing. That's why I put it in parentheses. That's going to be 21y, and that's equal to, what's that, 93? Yeah. And let's do the next one. So that's going to be a positive 15x, and that's going to be a plus 20y, and that's going to be 30. Oh, look at my line. Much better now. So now, the whole reason we did that is so we can get rid of the x's. Okay, now I could have done it for the y's. What would I have to have done if I wanted to get rid of the y's? I'd make it a 28, so I'd multiply this by a 4 and this by 7. Now what I would like to do, though, I would pick one of them. It doesn't matter which one, but I'd make the other one negative. Because I like to be consistent and add. I've heard some teachers say, well, if they're both positive, you would subtract them, right, to get a 0 out of it. I just like to always be consistent and just add all the time. All right, then I'm not worrying, do I subtract? Do I add? Okay, so that's what I'm going to do. So I always make sure that one is positive and one is negative. Okay, so now if I add them up, what's that add up to? 0, right? Cancels out. People say cancel out, but technically it adds up to 0. And then we add these up. What's that? 41y. We add these up. What's that? 1, 2, 3. And then y is equal to 3. We're not finished, though, are we? We're halfway done, though. Now, actually, the next part is kind of a substitution. What we're going to do is we're going to find out what x is equal to. Now, look, I got several equations. In fact, I have 4 different equations that have x in it, don't I? And so I can take that value for y and substitute it in, right, and then solve for x. It doesn't matter which one you use. It doesn't matter at all. But there's one in here that I think might be a little easier than the other. Which one would you rather choose? I would too. Yeah, because the numbers are smaller, they're positive, okay? It just makes things a little bit easier. So let's do that. So I'm going to use the 3x, that's what we're solving for, plus 4y. Now I know what my y is, I just found it, so it's going to be 4 times 3, and that equals 6. I don't have to worry about that 5 right there, okay? I just take the original equation that I started with. And then you just solve for this. This is easy. That's 12 equals 6. 3x. Subtract 12 from both sides. It's negative 6. Divide by 3, and x is negative 2. So I think he allows you just to, say x equals negative 2, y equals 3. But what you're doing here is you're actually finding, these are 2 lines. Like this equation, this first equation right here is a straight line. And this equation right here is a straight line. These lines are going to intersect each other. The point that we're finding right here is that point of intersection. Does that make sense? He did this with the graphing, right? Used the graphing calculator, and he kind of explained it that way. But that's exactly what you're finding. You're finding one line, you're finding another line, and what is the x and the y? It's where the 2 intersect because it's shared, right? Both lines have that same point in it. Do you see that? This line has that point, and this line right here has that same point. Are there any other places in these 2 lines where they share the same point? Nope. That's the only place where those 2 lines share the same point. And what is that point? That point is negative 2, 3. All right? I just kind of did a little rough line there, but that's what we're doing. So it's an actual point. It's an ordered pair. So a lot of books would like you to write it like this, as an ordered pair. It doesn't look like he cares. It looks like he is fine with just saying x equals negative 2, y equals 3. And that's fine. I wouldn't mind either. But you can have it either way, right? This I kind of stress to my kids to write it like this because you are finding the point of intersection between 2 lines, so you might as well write the answer as a point. You okay with that? All right. Tell you what, he does letter D on the calculator. That's perfectly fine, okay? It was pretty straightforward. I don't think I can show you anything different than what he showed you. It's just what numbers to punch in and stuff. Did you watch that on the practice? Or at least on the lesson? He punched it in and found the intersection. I thought what I would do, just be a little different, is solve by graphing. Actually, physically by hand. Graph by hand, okay? And then find out where that point of intersection is. And we should come close. I just want to show you that we may not get exactly it depends on the equation, how easy it is, if it comes out to be fractions and all that kind of stuff. But I think this is kind of important. Let's do this. Let's pause this. I'm going to get me some graph paper on here. Okay, here's my x and y axis. Now let's write the equation and let's graph the thing. So it's going to be 2x plus 3y equals 10. And then we have, tell you what, I'm going to write the other equation over here. I'll show you why in a second. Just to give me some room, that's all. I want to graph both of these equations. We did this earlier in the year, didn't we? Getting y by itself and graphing straight lines, rising and run. Did we do all that? We did that stuff, right? Okay. I have a bad memory, so it's hard for me to remember. So what we're going to do is get y by itself. I do this pretty easily. I'm going to take the y and put it over on the right side, make it positive y. Take the negative 7, move it to the left, which make it a plus 7. And then, so it's y equals 3x plus 7. So that's one equation. And I'm going to graph that. I'll do that in a second. Let's graph this one. A little more complicated, but it's not that bad. 2x plus 10. Divide both sides by 3. So divide that by 3, divide that by 3. This is where it gets a little bit hairy. All right, on the graphing anyway. So it's negative 2/3 x plus 10/3. 10/3 would be 3 1/3 since we're going to plot it. Okay. And just put that in a little box right there. And let's go red. We want to graph both of these. This is the easy one to graph right here. Let's blow it up a little bit more. Okay, so it's 3x plus 7, right? So let's go 7, 1, 2, 3, 4, 5, 6. Did I count right? 1, 2, 4, 5, 6, 7. I guess they're going 8. I thought they might go 10 for each one of those. Alright, so that's 7, and then the y-intercept is 3. Or, I'm sorry, the slope, we already did the y-intercept. The slope is 3. 3 over 1, right? 1, 2, 3 over 1, right there. Why does it look so scraggly looking right there? I don't know. So we can graph this thing, can't we? So let's make sure we start at one point, go through another one. This is where, even with this program, sometimes it might not be real accurate. I'll just extend it out a little bit. But there's that graph right there. We good? Let's graph this one. It's kind of off the screen here, but what was it? It was 3 1/3. This is where it gets a little weird, because a third is kind of a guess, isn't it? So you count up 3. 1, 2, 3. Go up just a little bit more, about right there. Okay? And then the slope is negative 2/3. It's off the screen. I'll just write it here. It's negative 2/3, which means we go down 2. Now look, I'm up a third, right? So I have to go to that same spot. So if I go down 2, that's 1, 2, and then over 3. 1, 2, 3. So it would be about right there. And now we'll connect those two dots. I think this is going to work out pretty well. All right. Now again, you could have done this in your calculator, or you could do it like this, so you can have a little bit better understanding instead of just plugging stuff into a calculator. So what did we say was true about that point? Remember, that point was the point of intersection, okay, of the two lines. And look where they intersect. They intersect right here. Let's blow that up a little bit so it's a little easier to count. Okay. So where is that? It's negative 2 and 1, 2, 3, 4. I said 3 though, didn't I? What was the answer? No, what was the answer to what we... Didn't I... Oh, I'm sorry. Yeah. I was thinking I was graphing the other equation we just did. Right, this is a new one. I was like, what am I doing? Yeah, it's negative 1, 4. That's exactly the answer that we want right there. Okay, so... Should have blown it up a little bit more like that. Yeah, so that's our answer. It's negative 1, 4. And if you put that into a calculator, all right, see that point right there? It's negative 1, 4. Worked out pretty well when you use straight lines and graph paper, right? If you're just trying to graph it on a regular sheet of paper and you're just like using your hand to draw the straight lines, it might not be that accurate. It might be off a little bit. But I was pretty close, right? That was about a third. That's about a third, so I was pretty close. And I kind of knew it was going to intersect there, so I kind of made sure that it did. But it worked out real nice when you have straight lines and that kind of thing. Calculator absolutely is a more accurate way to do it because it'll tell you exactly where it is. You don't have to guess. Even though the screen is real choppy looking, and you can't really see a lot of details in the screen, it'll still tell you where the number. You do the trace thing. Remember, he did all that kind of stuff. I'll just let you watch his version of that calculator problem. Okay, we good with that? All right. Let's do F. F is the word problem. Of course, everybody hates word problems, right? But that's why you do math. The whole reason that we learn math is so we can actually solve real life problems, and that's what it's all about. All right, what we're going to do is this word problem. It's letter F on that practice. And it talks about fountain drinks. It says a store recently ran a sale, blah, 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 on fountain drinks. It says a large fountain drink. I'm just going to write it like that. The large fountain drink cost $1.50. Guess they didn't go to McDonald's, did they? Because you can get a extra large for $1, right? Any size. And then a small for $1. Yeah, get the large, wouldn't you? 50 cents. All right, so, and then they told you that they sold 501 drinks altogether. All right, so they're selling all these drinks from the beginning of the day to the end of the day. They sold 501 altogether. I'm going to write total. I'll put total sold. Is that all right? Is 501. This is what I do. When I do word problems like this, I try to list out all the stuff that they tell you, and so it kind of makes sense to me. What else do they tell you? They tell you how much money they made, right? The total, we'll put total again, but the total money, put the dollar sign, okay? So the total money that they made was $689. $689. Nice profit for just selling soda. All right, 680. From what I understand, like gas stations and stuff like that, and even like McDonald's and like if you do concession stands, that's where they make all their money, is in the sodas. Because think of how much it cost to make a soda. Even a 2-liter probably costs just pennies. After everything's said and done, it probably costs more for the bottle than it does the actual soda. And oh yeah,
they have
soda,
carbonated water, and then they have their
the syrup.
Yeah, the syrup.
Yeah.
And
Yeah.
mixes them together.
And they charge. I mean, you go to a concession, like a game or something, they're charging like $3. Go to a movie, of course you get a big old bucket of soda, but they charge like $5 for it, But it probably costs what, 50 cents to make that whole entire bucket of soda. I mean, the profit they make on soda is just incredible. Anyway, that's it's a little off topic. So here we go. What we have to do is we want to figure out how many of each did they sold. We can actually, with this amount of information, we can find out how many large sodas they sold and how many small sodas that they sold without even keeping count, which is kind of interesting. So what we're going to do is we're going to do that system of equations. We're going to have two separate equations. One equation is going to deal with the number of sodas that were sold, the number sold. That's one equation. Then we're going to do another equation. It's the we'll just say the money. I guess that's the best way to say it. The money made, all right? Or the cost. Let's say that, money made. That's stupid. Let's say the cost of the sodas, okay? So we're going to have two equations. One is just going to deal with the numbers that we sold. Doesn't have anything to do with the money. And then the second equation we deal with just has to do with the amount of money that it cost, okay? Does that make sense? So let's just take the number that are sold. So how many were sold altogether? 501, right? So which types of sodas were sold? We have two types. We have a large soda and a small soda, correct? So he uses X and Y, and I hate when teachers do this. They'll say, okay, let's take, Susie and we'll make her X, and take Bobby and we'll make him Y. Well, why not make Susie S, and why not make Bobby B? You know what I mean? So what do you think I'm going to call this? I'm going to call large. I'm not going to make it X. What am I going to make it? Make it L. Yeah, might as well. Make it L. Okay? Doesn't that make more sense? Yeah, I think so. And what about the small? What are we going to make the small? S. Good. So we're going to go, if I add up the amount of larges that we sold plus the amount of smalls that we sold, what does that add up to? 501. You get that? Okay, so that was the number sold. So my first equation is just the number that are sold. What about the cost? Okay, or how much money they, made altogether. Well, how much money did they make? Yeah, between the large and the small, they made $689, didn't they? But I can't go L plus S equals 689, can I? This 689 is how much money. So think about it. Let's say I sold 2 large sodas, okay? Make it super easy. If I sold 2 large sodas, how much money did I make? What math did you do in your head? 150 times, not plus, times 2. Because what if I had 10? You wouldn't add, would you? What if I had 10 sodas? You would go 150, what? Times 10. Does that make sense? So you'd make $15 on 10 sodas. You follow me? So our equation, we're going to use the L, but what do you think you're going to do to that L? This is how many larges you sold. Like I sold 2 large, 5 large, 10 large. How do you figure out how much money you made just on the large? 150, exactly. So what do you think you're going to write right here? Yeah, 150 times L. Do you really need the 0 on this, though? No, because it's just 1.50, which is just 1.5, and we'll put an L there. Does that make sense? This is how much money you made just on the large sodas. Well, this is how much money you made altogether. So what do you think you're going to have to do? The large, what do you have to do to the small? You're going to add it, right? And what are you going to do with the small? Right, which really, I'll put it there just so that you know that you multiplied it by 1. But this could have been like 75 cents, right? All right, let's say it was 75 cents. What would you do? You'd multiply it by 0.75, right? But it's a 1, makes things really easy because it's 1 times S. Now look what you have. You have one of these systems of equations. Sometimes they call these simultaneous equations, all right? Because L is the same on both of them at the same time, all right? So now what we have to do is just solve. Now you could do, and actually it would be pretty easy to do elimination here. Because remember, yeah, you could just multiply by a negative and eliminate the S's, couldn't you? Right? Multiply this by a negative, that, and then the S's eliminate. But just for the sake of teaching, not for the sake of doing the problem the easiest way possible, but just for the sake of teaching, let's do this by substitution, right? Because there are times where it would be easier to do it by substitution. Maybe not in this case, but I just want to show you how to do it, okay? So what you could do, you could get this L by itself very easily, or you could get this S by itself very easily, all right? So what would you do? What if I wanted to solve for, let's see, what did I do? I solved for L. Might even be easier solving for S, but that's okay. Let's solve for L. So if I wanted to get L by itself on this first equation, what would I do? Subtract the S. Pretty easy, right? So 501 minus S. Now we haven't really substituted yet, but here's the substitution. Remember, the L up here is equal to the L down here. So L is equal to 501 minus S. So I'm going to take that and put it where? Yep, in the L in the bottom. Very good. You see what I'm doing? I'm just finding what L is equal to up here, stick it in the L here, and then look what I have. I have all S's, and then I can solve for S. Again, this is probably not the most fluid way, or the, I don't know what word I'm trying to think of. Efficient, that's what I'm thinking. It's not the most efficient way to do this, but it's a way to show you how to do substitution. So we stick the 501 minus S in here, 501 minus S, and then we just finish off the rest of this equation, right? There's the 1.5 L, right? Because that's L. And then we just finish it up. Plus what? S equals 689. And now we just solve for S. All right? 1.5 times 501, I've already done that. It's 751.5 minus 1.5S, and then plus S equals 689. See, now it's just basic algebra, isn't it? Let's add the S's together. We get, it's negative 1.5 plus 1, right? Would be negative a half S, or 0.5S. Let's subtract the 751.5 from both sides. And I already did that. That's negative 62.5. Divide both sides by negative 0.5. Divide that by negative 0.5. And S is 125. So that's how many small drinks, how many small sodas that they sold, 125. Remember, there was 501 altogether that they sold, right? So they were keeping track. They just forgot to keep track of how many smalls and how many larges. But they probably figured, we can figure that out anyway, right? If I just know how many total that we sold, how much money that we made, I can figure out how many large, how many small that we actually sold. Make sense? Now we can find large. How would I find large? Well, look at this equation right here. How do you find large? Just take the small away from 501, right? Because there's 501 altogether. So 501 minus 125. And how many larges did they sell? 376. It's kind of cool, isn't it? Not knowing how many of each that they sold, and you can actually figure that out just by that little bit of information. All right, so they sold 125 smalls and 376 larges. And you were right, Jacob. I think most people figured, you know what, for 50 cents I get a large. Yeah, we'll get the large. Yeah, exactly. Like I went to McDonald's yesterday. My buddy and I went out to breakfast. We had a planning period. We're like, I was done all my grading. I said, let's go out eat something. So he ordered a large drink and I ordered a medium drink. And he's like, you know what? If you get a large, it would be less money. It's only $1 for the large, right? And I'm like, oh, that was stupid then. But I found out that they charge $1 for all the sizes. So you can get a large for, and I didn't even finish my soda anyway. So it's a good thing I didn't get the large. I used to drink a ton of soda, and I hardly do. I might drink one soda a week now.
I don't drink very much soda, but when I'm doing.
Yeah, I used to drink. That's the only thing I drank. I mean, Pepsi was my thing, man. I mean, you should see my house. I like bottles and bottles of 2 liters of Pepsi, And if I was down to one bottle, I'd make sure I'd run out and get more. I mean, it was almost an addiction. It was crazy. And then one summer, like not this summer, but 2 summers ago, I teach at a yearbook workshop, yearbook camp, teach photography there. And for some reason, I just started drinking some juice. And I was like, you know what? I'm going to see if I can just quit drinking sodas. I mean, and believe me, I mean, it was addictive to me. I mean, I would drink it in the morning. I don't drink coffee. I drink Pepsi, I'd drink it for lunch. I'd drink it when I got home. I'd drink it at dinner. I'd drink it before I went to bed. I mean, that's the only thing I drank. And for a whole year, I went an entire year without drinking one Pepsi. Or I had a couple sodas, but I had like ginger ale. Like if I'm shooting a wedding or something, they don't really have juices, I'm not drinking alcohol, so I don't drink alcohol. So I would drink like a ginger ale or something. I think, seems like a healthier type soda. I don't know if it is, but it just seems like it. But I didn't drink one Pepsi for a whole entire year. I was so proud of myself. And then it's funny, a year later, at that same camp, right? It was the last day. I'm like, all right, I've gone a whole entire year. So I actually drank a Pepsi again, or it was a Coke, and my buddy took a picture of me drinking my first Coke after a year. But really, I haven't really drank that much. If I go to a restaurant, I always drink sweet tea. If they don't have sweet tea, I might get a Coke or something. But anyway, not that you care. Is it snowing? Is it snowing pretty good?
Yeah.
Yeah. Okay, let's do this one. This is lesson 65 now. Let's change colors. It's time to write in that. Let's go orange. I don't use orange that much. Is that your favorite color? All right. So what we're trying to do is we're trying to solve. And remember, I'm not going to do this again. He does another one like this where he uses the calculator and he shows the point of intersection. Remember, we had like a circle and like a parabola and that kind of thing. And I'll just let you look at that. And then what is it? X minus y equals 3, I think. Yep. X minus y equals 3. And this is a system of equations because, again, I want to find an x that works for this top one and the bottom one. And I want and a y that works for both of them. So I want an ordered pair, an x and a y, that makes these two sides equal and it makes these two sides equal. All right? It's going to be the same x and the same y. All right? Good.
Could we plug, since it says y equals already, could we plug all that into the y and the bottom?
You could, but I would do it another way. I think that would be a little more complicated. Actually, it wouldn't be. To tell you the truth, I don't think it would be. you could do that. You could put that in. I didn't do it that way, but I'm looking at it now that you mention it. I'm thinking, you know what? It may be a little easier doing it that way. It's not. I don't think it's going to make any difference. But let's do it that way. I didn't do it that way, but let's do it. You're right. Y equals all this, right? So let's take all that and plug it in for that y. All right, so let's give it a shot. So what we're going to do is write this bottom equation with all this mess in place of the y. You got to be careful, though, because you're subtracting the y. So you have to do what? Subtract everything here. So that means you put it in parentheses, okay? Now, if you can do that in your head, that's fine. I like to put the parentheses just to kind of remind me. Does that make sense? Okay, so there's my x minus y, right, equals 3. Now it's just a matter of solving for x. So let's distribute the negative. Make sure we do that. It's negative x squared. That's a plus 4x. That's a minus 1, and that equals 3. I don't like this negative x squared. Kind of looks like a quadratic now, doesn't it? I got an x squared, x, and a number. So I don't like that negative, so let's put it on the right-hand side. So that's going to give me x squared, right? This is a plus 5x, isn't it? 1x plus 4x. I'm going to put it on the other side again, right, with the x squared. So that's going to be what? Minus 5x. See what I just did right there? Did a little bit in my head, but I added 5x. Then I stuck it on the other side, which is going to give you a minus 5x. Right? So that goes. And then let's do the same thing here. This is a minus 1. Let's put it on the other side so they're all on the same side. So that's a plus 1. It would be a plus 4. I'm dumb because it's a plus 1. I'm looking at it. I'm like, what did I do? All right. Now, you could put the 0 on the left-hand side, but we usually put it on the right-hand side, so there we go. Either way you do it, I'll just show you what I won't show you, but I'll get you started on it. What I did was this. I took the y and got it by itself down here, so I just added a y, subtracted a 3, x minus 3. Take this and put it in for that y. All right. I think the amount of work is almost the same. This one you're going to have to is that what I did? Yeah, that's what I did. The work is pretty much exactly the same. So either way you do it is perfectly fine. So this is what we are left with. And so now I got to solve for x here, don't I? This actually factors real nice. They kind of rigged it a little bit so it would factor. So I put an x here and an x here. Remember this factoring? And then it has to multiply to be positive 4 and then add up to be negative 5. That would be a negative times a negative, right? To get a positive and a negative right here. So if I multiply, I get positive 4. If I add them up, negative 4 plus negative 1 is negative 5. That works. Set them both equal to 0. I know I'll go a little quick, but we've covered this in quite a lot of detail in the past. So we set them both equal to 0. Then we solve for x. So x equals 4 and x equals 1. So I actually have two different values for x. So what I have to do is I have to find what y is. Right? And yeah, this is definitely the easiest one to plug it into. You could plug it into this one, okay? And when I started doing this myself, took my own notes on this, I started plugging it into here. I'm like, why am I doing that? This is way easier, okay? It still worked. You got the same exact answer, but you're right. I always like to do it the easiest way, or I like to try to anyway. So, oops, what was it? It was y equals x minus 3, wasn't it? Oh, goodness. All right, here we go. Let's go different color here since we're plugging it into something different. Y, what did I say it was? Y equals x minus 3? Okay. But look, we got two different x's though, don't we? So I'm going to have to take one of these x's and plug it in and get an answer. And then I'm going to have to take another x and plug it in and get another answer. Okay? So when x is equal to 4, what's y equal to? Y equals 4 minus 3, so y equals 1. So look, we have 4 and 1. Again, these are ordered pairs. These are points of intersection where the lines intersect. Okay, so I've got 4, 1. That's one answer. But I also have x equals 1, don't I? So I'm going to have to do that. So I'm going to write x equals 1 right here. And let's plug in that. So it's y equals, what? 1 minus 3. So y equals negative 2. So that means when x equals 1, then y equals negative 2. So I actually get two ordered pairs. That would be 1, negative 2. See that? And the reason is because the one equation right here is going to be a parabola. This right here is just a straight line. I'm not going to graph it accurately here, but it's basically like this. Here's your x and y axis. Your parabola will look something like this, okay? And your straight line will look something like this. Again, I'm not being accurate on this. But why are there two answers? Why do you get two ordered pairs? Because there's two places where that straight line intersect the parabola. You see that? So one of them would be 4, 1, and the other one would be 1, negative 2. Got it? That's almost actually kind of accurate, isn't it? 4, 1, and then 1, negative 2. All right. That wasn't on purpose, but that was nice. Okay. Let's spend the rest of the time on this next problem. We got about 10 minutes, and it's going to take all of 10 minutes to do this next problem. It's a system of equation again, but it's 3 of them instead of 2 of them. And you're like, how much harder can that be? 3 compared to 2? Well, this one's actually not too bad. They make this kind of easy. But I'll just kind of give you, again, I didn't see how the guy on the video did it. I'll just kind of give you my take on it. And that's actually probably good that I don't just repeat everything that he does exactly. Because then you see 2 different, and I may do it exactly the way he does it, I don't even know. But you can tell me if it's much different. I would assume it's pretty close to the same. Alright, here we go. You can put the little bracket here, I'm not going to bother doing that. What we want to do is solve for x, y, and what? Z. So here's the deal. Up above we had x and y. So if you have 2 variables in your equation, you have to have 2 equations to be able to solve for it. Okay. If you have 3 variables in your equation, guess what? How many equations you're going to have? You're going to have 3 equations with those same 3 variables. Okay. So if I wanted to solve for x, y, and z, I couldn't do it with just 2 equations. I have to have a third equation, and here we have 3. What I'm going to do is I'm going to break it up. I'm going to decide what I want to eliminate. I'm definitely doing elimination on this, okay? So, I see something right away, don't you? The y's. I see that right there. They'll eliminate very easily. I don't even have to multiply both sides by anything to eliminate them. All I have to do is just add those first 2 up. So what I'm going to do is I'm going to take, actually, let's do it like this. I'm going to group these 2 together, all right, and figure it out. So with the magic of my little program, I don't have to rewrite it. I can just copy and paste. Don't you wish you could do that? And here we go. All right, so now look what happens. If I do elimination on here, remember I'm adding up everything, and the reason I can do that elimination is because this is already a plus and a minus, and it's both 2y. So let's add up everything here. I've got 3x plus negative 1x, or 3x minus x, which is 2x. These 2 go to 0. These add up to 4z. And this right here is, what's that, 18? Okay. Now, I could keep it like this. I don't know if he did or not, but I see something to make this just a little bit easier for us. Do you see that 2 goes into everything here? So why not just divide everything by 2? You don't have to do that, but I think sometimes it makes it a little bit easier. So divide everything by 2. So that's going to give you x plus 2z equals 9. I'm going to hold on to that. I always put it in a box, don't I? When I hang on to it. It's not my answer, so I don't circle it. Put it in a box, hang on to it, then I'm going to come back to it. What variables do we have here? We have an x and a z, don't we? So I need to use this third equation right here, and what do I need to get rid of? The y. I need to get rid of the y. So I could combine the first equation with the third one, right? Or I could combine the second one with the third one. Which you think might be a little bit better?
The second one.
Maybe the second one, because it's a plus and a minus already, right? That might make it a little bit easier. So, again, I'm going to copy and paste right here. Okay. What am I going to have to do first? I can't just add them up right now, though, can I? Because that's not going to eliminate the y. So what am I going to have to do here? Multiply what? Which one?
The bottom.
Bottom. Good. Okay, multiply the bottom by 2. Then make sure you do it to both sides. And then let's see what we get. So the top, I didn't change the top at all, did I? So that stays the same. What's the bottom going to become, though? It's going to be 2x minus 2y, right? That was the whole key to that, making that a negative 2y, so it eliminates. And we got a negative 2z, and that equals 14. And now we can eliminate. Actually, whatever. All right, now we can eliminate. The y's go away. Look what I have. I've got negative x plus 2x is 1x. And negative 3z minus 2z is negative 5z. Add up those, and that's a 2. I'll put that in a box. And now you make another system of equations. Exactly right. Okay, I'm going to take this one, and copy and paste it. If you're writing it down, you probably want to rewrite it. Okay, but let's see. Let's get rid of these lines here. And then let's take this one, copy and paste that, and put it right underneath of each other. You understand what we're doing now? And now I'm back to my earlier type of problem. What's the best way to do this? Probably multiply the bottom by a negative. You see that? So the x's eliminate. And we can kind of do this in our head here. It'd be x minus x, which eliminates. Now watch this. This is 2z minus a negative, which is plus, right? So that would be plus 5z. So you add them up, you get 7z. And then, again, that's a negative, so that would be a 7 divided by 7, z is 1. Once you get the first one, the other two are kind of easy to get. Look, this has an x and a z in it, doesn't it? So let's put it in for that. So x minus 5 times 1 equals 2. It's just a 5, add a 5, x equals 7. So we got z and we got x. Now we got to find y, don't we? You could, look at this one. This has all three of them. So let's put them in. X was 7, right? We don't know what y is, so we just keep it y. What do we get for z? 1 minus 1 equals 7. 7 minus 1 is 6, right? So subtract 6 from both sides. Negative y equals 1. If negative y equals 1, y equals negative 1. And there it is. This is there's actually 3 values for this. Instead of an ordered pair, it's actually an ordered triple. There's 3 of them, right? It's if you're dealing with like 3-dimensional things, okay? Instead of just a flat surface. We're not getting into that right now. So you could write it 7, negative 1, positive 1. That's an ordered triple. Don't know if he writes it like that. I kind of doubt he does. He probably just puts x equals 7, y equals negative 1, and z equals 1. And there you go. So we took care of both lessons, all the new stuff. We didn't hit any old stuff. Sorry about that, but, you know, you got the videos anyway. You can check that out. Okay, that takes us right to our time. Got everything done we needed to. Have a good week, guys.